For this topic with trigonometry, we are now going to be looking at trigonometric functions of any angle. And this means our angle is not just restricted to being in quadrant 1. It could be in quadrant 2, quadrant 3, or quadrant 4. So in order to begin this topic, we're first going to let our angle be an angle in standard position with point P defined as x comma y on the terminal side of our angle. So first, let's make sure we understand that this is our x-axis, this is our y-axis. Our angle is in standard position, which means the initial side is on the positive x-axis and the vertex is at the origin. Now I'm going to choose any arbitrary point on this terminal side. So I'm going to let our point P be here and recognize the coordinates of this point are unknown. It is x comma y. Now we've been working with right triangles, and we can get a right triangle from this by dropping a perpendicular from the point to the x-axis. And so now if we think about traveling from the origin to this point, we would go x distance to the right, y distance up, and then we have our unknown hypotenuse, which we actually call r. And so x in relation to theta is the adjacent side. Y in relation to theta is our opposite side, and r is the hypotenuse. Now the reason we call the hypotenuse r is if you think about the origin and a ray with a point, and we swing this around, we actually form a circle, don't we? And so the distance from the origin to this point is the radius. Now, coming from the Pythagorean theorem, x squared plus y squared is equal to r squared. Therefore, r is equal to the square root of x squared plus y squared, and it represents the distance from the point to the origin. And the other thing that we want to recognize, this is going to be very important, because r is a distance, r is always positive. Now, if we look at our angle in standard position, we can actually define our 6 trigonometric functions in terms of x, y, and r. So sine of our angle, well, sine is defined as opposite over hypotenuse, but that gives us y over r. Now the reciprocal of that is cosecant, and cosecant of any angle will then be r over y. Cosine of any angle is adjacent over hypotenuse, so our adjacent side is x and our hypotenuse is r, and the reciprocal is secant, and secant of our angle is r over x. And then our last pairing of trigonometric functions, tan of our angle is opposite over adjacent, so that is y over x, and the reciprocal trigonometric function is cotan, and cotan of an angle in standard position will give us x over y. Now this is a handy little chart for you to be able to refer to, and it's looking at the signs, positive or negative, of your 6 trigonometric functions depending on which quadrant your point lies in. So for example, if your point lies in quadrant 1, your x is positive, your y is positive. Therefore, everything is going to be positive in quadrant 1. For quadrant 2, x is negative but y is positive, and that's going to affect cosine and its reciprocal and tan and its reciprocal because they both contain x. So notice sine is positive. For quadrant 3, both x and y are positive. Therefore, tan of an angle in quadrant 3 is positive because a negative divided by a negative is positive. And then finally for quadrant 4, x is positive but y is negative. So sine will be negative and tan will be negative because they'll both have a negative in the numerator, but cosine will be positive because x and r are positive. Now we're going to expand this much more deeply so that you truly understand what's going on here. That's important. So let's go through quadrant 1 with a point 3, 4. So if we have a point 3, 4, that means x is 3, y is 4, and we can solve for r by using the Pythagorean theorem. So r is equal to the square root of 9 plus 16. R is equal to the square root of 25. R is equal to 5. So we have our x is 3. Y is 4. And r is 5. And this is our angle in standard position. So if we think about the signs of our 6 trig functions, where x is positive, y is positive, r is positive, they are all going to be positive. We can see this in brief if we look at cosine of our angle. Now remember, cosine of an angle is the adjacent side divided by the hypotenuse. So that is 3 over 5. Tan of our angle is the opposite side over the adjacent side, so that is 4 over 3. And so just looking at those two, you can see the x value is positive, the y value is positive, the hypotenuse is positive, everything is going to be positive. So all trigonometric functions of an angle in quadrant 1 are positive. For quadrant 2, let's look at the point -3, 4, where x is -3, y is 4. And this is the last time I'm going to solve for r. If we look at x, it's -3, but x has to be squared. Y is positive 4. 4 has to be squared. And so -3 squared is still positive 9, as we saw up above. So r is still the square root of 25. R is still 5. And that's going to hold true for the next 2 examples as well. So x is -3. Y is 4, and r is 5. And we will talk about the signs of our 6 trig functions as we explore sine and cosine. So sine of our angle is the opposite side over the hypotenuse. Notice it is positive because it's dealing with y and r. Cosine of our angle, and notice please our angle. Cosine of our angle is -3 over +5. And if you think about the other remaining trig functions, the only other trig function that will be positive is the reciprocal of sine. So sine of an angle in quadrant 2 is positive, and cosecant of an angle in quadrant 2 is positive. For quadrant 3, we have x is -3, y is -4, but r is still going to be +5 because a negative squared is a positive. So if we look at this triangle, so x is -3, y is -4, and r is 5. So our angle is all the way there in quadrant 3. And we're going to talk about the signs of our trig functions by looking at sine of our angle. So sine of our angle is opposite over hypotenuse. And notice that is negative. But if we look at tan of our angle, which is opposite over adjacent, that actually becomes positive, which will hopefully help us understand that only tan of an angle in quadrant 3 is positive and its reciprocal, so cotan of an angle in quadrant 3 is positive. All of the other ratios are negative, as we can see with sine. For quadrant 4, we have x is equal to 3, y is equal to -4, but r is still equal to +5. So x is positive, y is negative, r is always positive, and in this case r is +5. And our angle, and so thinking about the signs of our 6 trig functions, we will explore that by looking at cosine of our angle, which is adjacent over hypotenuse. Notice cosine of our angle is positive because it deals with x and r. But sine of our angle is negative because it deals with y over r. So the only trigonometric functions that are positive in quadrant 4 are cosine and its reciprocal, which is secant. The other 4 trigonometric functions will be negative. So let's explore for a moment and determine which quadrant does the angle lie in if sine of the angle is positive. Well, sine of an angle is positive if it is in quadrant 1 or quadrant 2. Be careful with your signs there. Cosine of an angle is negative, less than 0. Well, cosine is positive. Everything's positive in quadrant 1, but cosine is also positive in quadrant 4. So that means cosine is negative in quadrant 2 or 3. And where are both situations occurring? And that is quadrant 2. So our angle lies in quadrant 2 if sine of the angle is positive, but cosine of the angle is negative. You have 5 questions. Which quadrant does the angle lie in if cosine of the angle is positive and sine of the angle is negative? Question 2, which quadrant does the angle lie in if cosine of the angle is negative and sine of the angle is also negative? Question 3, which quadrant does the angle lie in if cosecant of the angle is positive and secant of the angle is negative? Question 4, which quadrant does the angle lie in if tan of the angle is positive and sine of the angle is negative? In question 5, which quadrant does the angle lie in if cotan of the angle is negative and cosecant of the angle is also negative? All right, so we're going to combine what we've been talking about for this next question. We're going to notice that sine of the angle is negative 3/8. So we need to think about first, where is sine negative? Now, one of the nice little mnemonic devices that we can help remember where different trigonometric functions are positive or negative is given by this little diagram right here. And the A stands for all, and it means all trigonometric functions of an angle in quadrant 1 are positive. The S in quadrant 2 means sine of an angle in quadrant 2 is positive, but so is its reciprocal, cosecant. The T for quadrant 3 means tan of an angle in quadrant 3 is positive, but so is its reciprocal, cotan. And the C for quadrant 4 means cosine of an angle in quadrant 4 is positive, and so is its reciprocal, which is secant. So if sine of an angle is negative, the angle cannot be in quadrant 1 or 2. It could possibly be in quadrant 3 or 4. But we also know that cosine of the angle is positive, and cosine of an angle is positive in either quadrant 1 or 4, and where both of these situations are occurring is in quadrant 4. So our angle lies in quadrant 4. So angle lies in quadrant 4. Now the next thing we want to do is write that negative so that it actually makes sense. So we're going to remember that sine of our angle in standard position is equal to y over r. And r is always positive, so that means the negative is the 3 and the positive is the 8. And that's going to help us draw this. So y is negative 3, r is positive 8, and we don't know the x value, but we need to know that because tan of an angle in standard position is y over x. So we know the y is negative 3, but we need to find the x. So in order to find the x, we need to use the Pythagorean theorem. So negative 3 squared plus x squared is equal to 8 squared. So 9 plus x squared is equal to 64, and subtracting 9, x squared is equal to 55, and x is either positive or negative square root of 55. But what quadrant are we in? We are in quadrant 4, and is x positive or is x negative in quadrant 4? X is positive, so x is the square root of 55. So that helps us finish our problem. Tan of our angle is equal to y, but y is negative 3, over x, and x is the square root of 55, and we need to rationalize as always. So we're going to multiply by radical 55 over radical 55. So tan of our angle is equal to negative 3 times the square root of 55 over 55. And our last topic for this very long video is we're going to use our calculator to find the value of sine of 254 degrees. But before diving right into our calculator, I want us to understand why our answer will be either positive or negative. So if we think about where 254 degrees lies, so there's 180 degrees, and this is almost to the y-axis, but not quite. This lies in quadrant 3. And what do you know about sine of an angle in quadrant 3? Now remember, sine is only positive in quadrants 1 or 2, but this angle lies in quadrant 3, so my answer will be negative. So when we plug this into our calculator, this is approximately negative 0.9613. And your job is to find the value of tan of 254 degrees. And I do want you to take some time. Will your answer be negative or will it be positive?